Okay, in this video, this is John Marsh, NCS 450, 541. In this video, I'm going to do problem 3 from homework 2, which is about the layer 2 frame check sequence, FCS. It says, create a flow chart showing the actions of layer 2 takes to use the FCS for error checking. So basically, the story is that we have our transmitter and we have a receiver, and the transmitter assembles the frame. Basically, we've got you've got the header, we've got the payload, and this is the Ethernet, or the IEEE 802.3 here standard, and this is also known as the MAC layer. So this is really only part of layer 2, but this is the MAC layer that we're considering right now. Okay, so it has the header and the payload, and then at the end it's going to tack on the frame check sequence, and it's going to calculate that. Starting with the header, it's going to take all of these bits and do a calculation to calculate the frame check sequence. And the frame check sequence, if you go to the notes and look, is 4 bytes at the end. So it's 32 bits long, and it's calculated using all of the bits in the frame. It doesn't use the preamble, but starting with the destination address, all of the bits in the header. So they're used to calculate the frame check sequence. It then appends that as a trailer. So we have a header and a trailer, and then it transmits it over to the receiver. The receiver, what this guy does is he takes that whole thing. Here's the FCS. He does his own calculation of the frame check sequence based on all of the bits except for the for the FCS itself, and then is going to compare those two values. And the crucial part is that if the comparison works, that is, if they're equal, then they keep the frame, and if they are not equal, the frame is thrown away. And so we could write a flow chart that says that the transmitter calculates the FCS. Next step is that the transmitter appends the FCS to the frame. So this is a flow chart showing step by step. The transmitter transmits the frame to the receiver. Rx is the receiver, Tx is the transmitter, and then over to the receiver. The receiver strips off the FCS, or removes the FCS. The receiver calculates its own FCS, and then the receiver compares the received FCS on the two FCS values. And remember, they're 32 bits long. It's 4 bytes at the end of every frame. If they agree, then we process the frame. If they disagree, then we discard the frame. Okay. I think officially in a flow chart, I'm supposed to draw a decision box like this. Let me draw it quick for you. Normally you have a bunch of steps here in a flow chart. But then when you come to a decision, it's some sort of a triangle like this, and it gives you two ways to go, yes or no. And then you go on to different parts. And then you may even go on to more decision blocks. But in general, the decision block is given as some sort of a diamond shape. Okay, and this is what they're supposed to look like. I obviously did not make my decision block a diamond shape here. In any case, that's the idea. The frame check sequence is much shorter than the whole frame. Obviously, it's only 32 bits long. However, there's an overwhelming probability that if the frame check sequences don't agree, then the frame was in error. Okay. In fact, if they don't agree, then yes, the frame was in error. It's possible for the frame to be errored and for the frame check sequences to agree. Okay, but it is very unlikely that that's going to happen. Okay, so that's the idea there. Basic error checking.